Hey Jonathan, so here's number three, and they want us to do it like like it was done in example one, which is evaluating an integral using its definition with limits. So that definition is given the limit as n approaches infinity from the sum from I equals 1 to n of f of c sub I multiplied by delta x sub I. And they say let c sub I equal 3i squared over n squared. So that's what this will be here. So first of all, we have to find delta x sub I, which is the width of the rectangles. So the end rectangle is this one, 3i squared over n squared. That's the x value of the very last rectangle. So if I subtract the previous one, which would be represented by I minus 1, then I get the delta x sub I, which is the width of the rectangle. So 3i squared over n squared minus 3 times I minus 1, the quantity squared over n squared. If you do some algebra, you get negative 6i minus 3. It's actually 6i minus 3. Sorry about that. I forgot to take out that negative there. It's 6i minus 3. Okay, and so now we're going to use the limit. So the f of c sub I means we're going to substitute c sub I into the function, which is the square root function. So this, filling in this part, becomes the limit as n goes to infinity. I equals 1 to n of the square root of c sub I, which is 3i squared over n squared, multiplied by delta x sub I, which we just found right there. Okay, so cleaning it up a little bit, the square root of I squared is I, the square root of n squared is n, and 3 is still left under the root, so I left it there. So that becomes the square root of 3. If I multiply through by I over n, then it becomes 6i squared minus 3i over n cubed, which then equals, if I factor out an n cubed, the square root of 3 over n cubed, and I'm left with 6i squared minus 3i. Well, we know that I squared is equal to n times n plus 1 times 2n plus 1 over 6, and we know that I is n times n plus 1 over 2. So substituting that in, or I should say the sum of that is, sorry, because we're getting rid of the summation. So the sum of I squared is n times n plus 1 over times 2n plus 1 over 6, and the sum of I is n times n plus 1 over 2. Sorry about that. So we can factor out the root 3 over n cubed because that's just a constant, and we're left with this. And it's still the limit as n goes to infinity. So then we have a whole lot of nasty algebra to do. The only thing from here to here is I got a common denominator of 6. So inside the parentheses here, I multiplied numerator and denominator by 3 to get a denominator of 6 right here. And then I'm not going to show you the algebra. I know you can do it. I just took 6 times n plus 1 times 2n plus 1 minus 3 times 3n times n plus 1 all over 6, and I came up with this polynomial right here. And then I distributed the n cubed through the denominator, and the limit as n goes to infinity, if I just look at this expression right here, these two terms, 9n squared and minus 3n, are insignificant. The n cubes cancel, and I get 12 over 6 is equal to 2. So I get root 3 times 2, which is equal to 2 multiplied by the square root of 3. All right, hope that helped. Enjoyed working with you and looking forward to working with you next time.